Welcome to Q&A Wire.
Okay, we're being asked to first find the critical numbers of f of x. So the way we do that is we take the derivative and we set it equal to 0. So in this case, we're going to apply the product rule and chain rule. This will give us 4x cubed times x minus 1 cubed plus it's going to be x to the fourth, and then you bring down the 3, and then it'll be x minus 1 squared. Take the derivative of the inside, but that's just 1. And then you simplify this, and you actually expand x minus 1 squared. So if you expand it, you get some more simplification, and it comes down to x minus 1 squared times 7x to the fourth minus 4x cubed. And we set this whole thing equal to 0. So we know that for x minus 1, we know that if we plug in 1, we get 0. So we know that for one of the values are 1. And then for 7x to the fourth minus 4x cubed equals 0, we can pull out an x cubed. It'll be 7x to the minus fourth equals 0. So now we have our critical values are x equals 1. We already know that from x minus 1 squared. And then we know 0. So we plug in 0, we get also. And then for 7x minus fourth, if you solve for that, you get 4/7 as well. And then those are our three critical numbers. So now for the second part, so the second derivative test, what we're going to do is plug in these values. So you first have to take the second derivative. So we take the second derivative, and again we're going to apply the chain to the product rule, and it comes down to 6x squared times 7x cubed minus 15x squared plus 10x minus 2. Sorry about that. And then what you're going to do is you're going to plug in values. So you're going to plug in the critical numbers. So if we plug in f prime of 0, we get 0. And if we plug in f prime of 1, f double prime of 1, you also get 0. And then if you plug in f double prime of 4/7, you get approximately 2.4, and that's greater than 0. So what does this mean? Well, when f double prime is equal to 0, that's an inflection point. So that means that there's a sign change occurring between numbers less than 0 and after 0. And then another sign change occurs at 1. So numbers less than 1 and greater than 1. And then at 4/7, we have a positive, which means there's a concave up, which means there's a local min happening. So the second derivative test doesn't exactly tell us what the sign changes are happening. So the only way you do this is you create a sign chart for further evaluation. But you can so you would have to do a sign chart to figure out exactly what are the exact signs that are changing. But the second derivative tells us that there is a sign because there is an inflection point occurring. And it's asking us, the next question asks us C, what does the first derivative test tells us? So what it tells us is that, well, we have already taken the first derivative test, so we have to do a sign chart analysis. So we're going to create a sign chart like I've done before. So this one's going to be a little bit bigger. So if we look at it, there's three really main component parts of f prime. So we have x minus 1 squared, and we have 7x to the fourth minus 4x cubed, but we've broken that down into x cubed times 7x minus 4. So we're going to take it in the piece by piece part so that we can evaluate it much more easily and quicker. So we have x minus 1 squared. So that's one of our line. And then we have x cubed. That's another one of our line. And we have 7x minus 4. That's another one of our line. And we're evaluating it from 0, 4th, 7th, and 1. So this is our number line, as a reminder again. So for x minus 1 squared, we know that anything squared will have all positive, so this will be all positive. And then for x cubed, any number less than 0 will be negative, and then anything positive will be positive. And then for 7x minus 4, if we plug a number less than 0, we get a negative number. If we plug a number between 0 and 4/7, like such as 1/2, you get something like 14/4 minus 16/4, and that's negative, so this will be negative. A number between 4/7 and 1, so we can take 3/4, and so 7 times 3 is 21, so 21 minus 16, that's positive, and this will be positive. And then we multiply it to get our sign of f prime. This will be negative times negative is positive, times a positive is positive. Positive times positive is positive, times negative is negative. And then this is all positive, and this is all positive. So we know it is increasing, decreasing, increasing, and increasing. And what's interesting is here that the first derivative test tells us where both the local max and local min is occurring, whereas the second derivative told us only the local min. So at 0, we know that there's a local max because it is increasing and then decreasing. So local max at 0. And then we know that there was a local min at 4/7 because it is increasing and then it is decreasing then increasing. And that was confirmed from our second derivative test. And we also know the behavior of the function. So we know that it's increasing, decreasing, and then it increases forever. And the second derivative test doesn't really tell us that. And I feel like the first derivative test is actually really valuable. It's a little bit harder to see the concavity of the graph, but it can be seen through this through the first derivative test with careful analysis, like as we did in this case. And yeah, that is the things that the first derivative and the second derivative test tell us. So there's definitely a limitation for what the second derivative test can tell us, but the first derivative test, all the information is there. It's just a matter of analyzing it and thinking more about the graph. And the second derivative test kind of just confirms what we think about the shape, or helps us, have a better picture in our mind about what the exact shape of the graph will be.